Alright, this is another screencast on open covers and finite subcovers. And here I have a number line. And what I'm going to do is that I'm going to show you some open covers of 0, 1 closed. One of our favorite things to look at. So I just want to look at between here and here. And then I'm going to show you some non-examples, and then I'll talk about the finite subcovers. So the idea of an open cover is I'm going to pick some open sets that completely overlap this. And so I can do it with one open set. And namely, I could do it with just one open set by picking, say, -1, 2. Notice if I pick the open set, I have to have I have to have the little circles there. Notice this completely covers up this black part right here. That's why we call it covers, because we think about it as covering up. So that's one example. Here's another example using 3 open sets. And I'm going to start by making it look like I'm going to do it with 2, and then I'm going to realize I made a mistake. So how about if I do -1/2, 1/2, and then I'll choose 1/2, 2. So I'm going to do it with these 2 open sets. And let's see, here's -1/2, 1/2, and here's 1/2, 2. Does that completely cover it? Oh no, right? I made a mistake. The number 1/2 isn't covered. So I'm going to throw in a different open set. How about 1/4, 3/4? And now look, this black part is completely covered by the 3 green sets. So those are all examples. Those are 2 examples of open covers. This one has 1 open set. That one has 3 open sets. Very soon you're going to see an example with an infinite number of open sets. But I want to give you a couple of non-examples. So, not an open cover. Zero, 1 is not an open cover. Why is that? My non-examples will go over here. It's not open cover because I'm not covering up 0. 0 is in the set, but it's not covered by the set. So if I take the union of all these, there's only one of them, 0 is not in there. So that's no good. So here's another example. Another example. See how visible yellow is. I'm going to pick 0, 1/2, and then I'll pick 1/4, 2. So 0, 1/2 is 0, 1/2, and then I need 1/4, 1/4, which is open, and then it goes all the way to 2. Look, all the black is covered by this. The problem is it's not open. This is not open. So it's not an open subcover, so I can't use this one either. So those are some examples of open covers and a couple non-examples of open covers. Now I want to get to, I'm going to show you an infinite open cover, and I'm going to show you, I'm going to talk to you about finite subcovers. So again, let's try to cover 0, 1. So now my strategy is going to be my open covers. Oh, and by the way, right now I'm going to just cover the open interval 0, 1. My open cover, by the way, an easy open cover would be just to pick 0, 1. But we're not going to do that because that's too easy. So I'm going to pick instead, how about 1/n, 1 minus 1/n. And when I do that, I get a bunch of covers that look like, I don't know, 1/2, 1/2, which is not much. Then 1/3, 2/3. I get a bunch of open covers like that. They just get a little bit longer every time. And you can imagine that eventually everything here would be covered. The problem is if I just take a finite number of them, they're going to be containing the kind of the longest one, which doesn't stretch all the way to the end. Whereas, if I instead consider, let's not consider this, but let's consider this, now this set is not an open cover because I'm never going to cover 0 or 1. So instead what I can do is I can choose open covers. I can also pick, say, -1/4, 1/4, and how about 3/4? We gotta stop this. Sorry.